Ready to go. So same setup as the first experiment with the metal at constant temperature. This is just a metal not at constant temperature, because remember, a filament is just a little metal that will get hot as it goes along. Okay, so what we have again is we have a potentiometer with the two red leads connecting to either end of that. So the power supply and the variable resistor act as a variable power supply. Okay, at the moment I've just right over to this side, so effectively the voltage will be 0 when we set it up. We are using, we need a milliammeter, so we don't have a milliammeter, so we're using a multimeter set as a milliammeter, so effectively it is a milliammeter. Okay, so what we have is, okay, and try to see, can we get this? Okay, the dial is connected to 200 M in amps, so that means it will measure up to 200 milliamps, and there are 3 connections in a multimeter always. Okay, there's always a common, okay, so you can see there, okay, you can, common, okay, and in this case we have connected to MA for milliamps. Okay, so that's it. Right, so we're ready to roll. Okay, so all we have to do is put in the multimeter, or sorry, the voltmeter. Okay, so the voltmeter will go in here. Okay, try to set it up so that we'll be able to see it. Okay, and remember, it's like a defibrillator, you just connect it across the 2 points you're interested in. In this case, we're interested in across the bulb. Okay, so we're ready to roll. Okay, I have the voltage at over 10 volts because I want us to get up to 10 volts. So I need a power supply of over 10 volts for that to happen. So at the moment we're at 0 and 0. Okay, so we're going to move it up to 1. Okay, so it's going the wrong direction, so I haven't connected this correctly. So I need to just reverse the connections. No big deal. Okay, this is what you call a moving coil meter. Nice old-fashioned meter, but it's easier to see it moving up to 1. It's very nice. Okay, so we get to 1. Take your reading. Take it to the nearest milliamp. So that's 34 milliamps now. MA. You have MA in your diagram. Remember, that'll be relevant when we get the resistance later. Okay, 2 volts. Right. Okay, so it's gone to 49 milliamps. Okay, so I've got to get you to read the rest. Note as the voltage goes up, there's more current passing through the bulb, and the bulb is beginning to light. Okay, so we move it up to 3. Okay, so take your reading to 4. Take your reading, nearest whole number, to 5. Take your reading to 6. Take your reading to 7. Take your reading to 8. Take your reading to 9. Take your reading, and finally to 10. Take your reading. You'll notice that it's now very bright, and clearly, if I put my finger on that, it is warm. Okay, so this metal is no longer at a constant temperature. Okay, so you have your 10 readings. So what we need to do now is draw a graph, V against I. Okay, we're going to find the slope of the 2 tangents at 1 volt and at 8 volts. Okay, and from the slope of the tangents, using our slope formula, we are going to get the resistance at 1 volt and at 8 volts, and that will give us an indication of what's happening to the resistance as the metal gets hotter. You're also going to indicate whether Ohm's law is obeyed or not. No, it should be pretty clearly it's not obeyed in this case. When you're drawing it in, it'll be a smooth curve, a nice smooth curve. Like a straight line with good fit, a curve with good fit doesn't have to necessarily go through all of the points if that doesn't work out. Although in this case it probably will. Okay, there you go.